Guys, a very good afternoon. This is Anand Kumar, and welcome to my video lecture series number one for this month of April. So, let us just start with an interesting topic considered as operating systems. In the operating systems, we'll just start up with a single topic called file systems. So, before going into the file systems, we'll just start with something relevant of discussion to the file system, that is operating system. Is like we'll start with what is the term called file concept, and what are the various access methods, and regarding the directory structure, what are the considerations we have to make, and regarding the file systems, what are the mounting systems we'll be using. I mean to say, we'll just see about file system mounting, and next we'll just go with about the sharing system of the file system concepts, and next is the most important thing, that is what we call as security. That is, we can take it as file system protection. Okay, let's start with the introduction part. The operating system defines a logical storage unit called a file. Considering the operating systems, whatever the information or whatever the data you have to store, or I mean you have to store, is like to include that as a file. I mean to say, file is said to be a logical storage unit, a minimal logical storage unit. The files are stored in the disk blocks in the disk. I mean to say, files are not stored right away in the RAM, or not right away in the motherboard. It will be stored in a hard disk. Here, the disk block is said to be a part in the local disk. And next, the important thing, that is what we call as mapping of files onto the disk physical devices, is done by the operating system. So, considering the essentialness of the operating system, what is operating system doing regarding the mapping? It just maps the file system or file number system into the into the physical devices. So the physical devices are non-volatile. What I mean with the term called non-volatile? Suppose if the current, or suppose if the power is lost, if the data is getting lost, or if data is erased, means it is said as a volatile memory. Considering the hard disk, it is said as to be a non-volatile. I mean to say, there is power, it will be storing. If there is no power, it won't be erasing. The stored data will be always there in the hard disk. So next is information is stored on a different storage media. I mean to say, if there is more storage devices or more storage medias, or if there is more storage partitions, each information can be divided and split, and it can be stored in different places. For example, here the physical devices are represented using hard disks, pen drives, etc., and they are used to store informations. And coming to the major important thing, that is, in a disk, the data are stored in small units. As I told you in the previous slide, it is stored in a small unit, and it is what we called as a disk block. So this disk block, of course, it is logically divided into disk blocks, which data is stored, as I told you. So the user may need not know about what is the term called disk block, or what are the information stored in disk block. We can just store the data in a hard drive. It is enough for the users to understand information in terms of files. As I told you, the file can be numbered, a file can be named, and the user can just understand about the file system naming. So what we are going to learn in this module is that we can learn about the uses of files, the file system, and the different attributes and the types of file system, and about we can just see about what is file system operations. And of course, we'll just see with different file access methods. As I told you, file is a named collection of related information that is recorded on secondary storage. And to be noted, here information is different from data, and data doesn't give any mapping to the information. So the file is the smallest allotment in a secondary storage. Secondary storage here depicts what we call as pen drives, hard drives, or physical devices. A file may represent program or data, and of course, to be noted here, I mean to say in this fourth line, that is, a file may be a program file or a data file. So the literal meaning of this line, that is program file or a data file, is that a program can also be stored as a file. That is what you call as program file. I mean to say, it can execute a different program, or it can execute a different function. And a data means just a reference program, or a reference file. Information can be stored in terms of data files. So the program files can be a source programs, object programs, and so on. And the data files can have, of course, the day-to-day life usage. What we are going to see is about like numerical data, alphabetical data, alphanumeric data, even binary data can be processed and stored in terms of file. So And to be very, very noted here, a file has a defined structure depending on the types of file. For example, let's have an example here. The text file is a sequence of characters. I mean to say, just read this line, just see this line. The text file is a sequence. I mean to say, it is about continuous thing. Let us complete this sentence like a sequence of characters organized into lines. I mean to say, a text file will be containing some texts and it will be stored in a secondary storage device, and that will be mapped in terms of physical devices using the operating system. As I told you, a source file has a source program and a sequence of built-in functions organized as declarations followed by executable statements. Guys, for your information, I'm just reiterating it this line and re-explaining this. A source file does have some source programs. Considering C program file, the C program file can have any program file. Just for example, I'm just referring adding up of two numbers that can start with some initial header file inclusion and some sequence of subroutines and functions. I mean to say the functional calling from storing up of a variable, storing up of b variable, calculation of a plus b, and storing up of a plus b in the c variable, etc. And of course, some declarations followed with executable statements. I mean to say, int a is equal to b, int a is equal to 10, or int b is equal to 10, int c is equal to a plus b. And of course, some executable statements like printf and scanf statements. This statements which I have stated here is for program code, source program code. So an object file can also have a sequence of bytes organized into blocks understandable by the linker. I mean to say it won't be literally understood by the what you call user or end user. It can be understood by the linker or the backend document or the programmer. So an executable file has a series of code sections that the loader can bring into memory and execute. Guys, for your information, any code or any program file or any source file or any file will be taken into the memory for execution. So with this thing, I'll just stop my class for this video lecture series number 1. We'll continue the rest in video lecture series number 2. Thank you for listening. Thank you.